This video will cover the Year 9 Algebraic Expressions Test Preview. This is the application section, so these are the sorts of questions you should expect at an A and B level in this topic. I'll put some time tags below with question numbers for those following along with the test preview sheet, and I'll put some descriptions there for others who would like some help with particular sorts of questions.
Okay, question 1A is asking us to fully factorise some expressions. Now, talked a bit about this in the fundamentals preview in question 5. We're trying to find the highest common factors of all of these terms. So basically what we're going to end up with is some brackets and as much as we can get out the front here, okay, as many common factors as we can. So first of all, have a look at the numbers. What goes into 4, 12 and 8? 4 will, so we'll take 4 out. Then have a look and say, have I got m's in all of these? Yes, I do. I'm going to look for the lowest number, okay, and that is the maximum that I can take out. So I know I can take m squareds out because they'll go into each of these terms. And then I'm looking at c's. There are c's in all of these as well, so I'll look for the lowest number. It's 2, so I'll take c squared out as well. And now it's a case of filling in what I've got left. So I know I've got 1m left in that term. And then I've got -3 here because 4 times 3 makes -12. And then I've got 2m, so I need another 2. I've got 2c, so I need another c. And then in the final term, I'm going to have a 2. I've got m squared, but I need some more c's, so I need c to the 3. And then if you expanded that back out again, that's what you'd get. And that's the test for it, okay? This times this makes that. This times that makes that, and that times that makes that. Question 1b, I'm looking for the highest common factors of these two terms so that I can factorise it. So again, what I'm going to end up with is brackets and as much out the front as I can, taking the negative factor where I can, okay? So I'll definitely be able to do that this time. What goes into 21 that also goes into 9? 3 does. And I can take the negative, so I'm going to take -3 out the front. I've got v's in both, so I'm looking for the lowest number. I can take those out. I've got m's in both. I'm going to take the lowest number, so 3. I haven't got n's in both, so they can't come out at all. Let's finish this one up. So I've got 7. I need an extra v. I need another 2 m's. I've got 3, I've got adequate v's, I've got adequate m's, I just need an n, and it's fully factorised. Question 2 has got some interesting examples in it, and so if you're really struggling to factorise, you're probably better off skipping to question 3 and watching me do some of these ones, because some of these are what we call perfect squares, and there's some clues for the more advanced students in this to see how you can factorise these easily. The thing that jumps out here at me is that that can be square rooted, and so I can also see there's a negative there, which would suggest to me that this is probably going to work out to be a perfect square. So if I square root 16, I get 4, okay? And because I can see that I've ended up with a -8 here, I know that this question straight up is going to be m minus 4 multiplied by m minus 4, okay? The thing that makes it a perfect square is that it could be m minus 4 all squared. And that's fully factorised, and that's what we call a perfect square. Right, question 2b is not a perfect square, but there's a big hint here. Do you see how there's no term in the middle? It's missing. So if you cast back to 1a, you can see that that can be square rooted and it's a positive number. Okay, so we know that one was going to work out to be a perfect square. In fact, if I skip ahead, I can see this one probably will be too. But this one here has a negative number. Now, the square root of 36 is 6, but it's not that straightforward, because to get a negative answer like this, you need a positive and a negative number, okay? So we know straight away that this one is going to be c minus 6 c plus 6. Because when you expand this out, the negative 6c and the positive 6c are going to cancel one another out, hence that term being missing in the middle. But we can still answer this one quite easily. Question 2c is going to be another one of these perfect square ones, and I can tell that because we've got a number on the end, a term on the end that can be square rooted, and we know the square root of 25 is 5. It's a positive number, and we know that 5 plus 5 makes 10, so everything's going to work out nicely. So it's going to be w plus 5 multiplied by w plus 5, or better written as w plus 5 squared. Question 3 is going to have some questions in it that are not perfect squares, like question 2 up there. So these ones are good examples to have a look at. There are a few ways of doing this. This is just my way of doing this. This works for me. With lots of practice, this is a fairly easy way for me to do it. So have a try and see what you think. What I would do is I start scanning through my head of all the factors of 24 that I can think of. So I know I've got 1 times 24, I've got 2 times 12, I've got 3 times 8, and I've got 4 times 6. And when I'm doing this, I'm trying to match these factors, okay, to try and make the number negative 2, okay. So there's no way that the combination of 1 and 24 is going to give me 2. In fact, none of these are going to work except for this one. So I'm saying, how do I make 4 and 6 give me the answer negative 2? And if I do positive 4 minus 6, I will get minus 2. So then I just write my answer in as, filling in the blanks, positive 4, subtract 6. And that's my answer. 3b is the same. I'm going to go looking for factors of 12 that will make 8. Okay, so ultimately I'm going to end up with m, okay. I know everything's going to be positive at this stage as well, okay, so I could even go through and do that, but that's given to me by this and this, okay. But anyway, let's jump back. We've got 1 and 12, we've got 2 and 6, we've got 3 and 4. That jumps out at me, okay. 2 plus 6 makes 8, so we'll say positive 2 and positive 6, and we've solved that. Alright, 3c, skipping through, I know I'm going to end up with x, so I'll write those in. And now I'm looking for factors of 36 that will make 16. So I've got 1 and 36, that clearly won't work. I've got 2 and 18, that'll work. 2 minus 18 would make minus 16, so we'll go 2 minus 18, and it's solved. Question 3d is a bit different. Do you notice how it doesn't have a term on the end that's just a number like these ones, okay, or like this one even? So this one's not going to be a binomial, okay. This one's going to go back to, we're going to drop some brackets in, and we're going to take as many high common factors as we can out the front. Now, there is no number that goes into 4 that also goes into 5 except for 1, so forget that. But we've got x's in both expressions, so we can take x's out the front, and that will leave us with 4x here and negative 5 here. And that one is now factorised. 3e, there's a couple of ways of doing these ones, but let's make this easy for ourselves. The first thing that I can see here is that 4 will go into each of these. So let's get that out the front, okay? We can get 4 out the front of x squared plus 6x plus 5. And now this is much friendlier to work with because we can just ignore the little 4 out the front for a bit and just treat this like a normal binomial, okay? So I've gone back to looking at the last term, and what factors of 5 can make 6? Well, there is only 1 times 5. Conveniently, 1 plus 5 makes 6. So that means that when I fully factorise this, I will get, just like in the questions above, I'm just filling in the blanks, okay? 1 and 5. And now that is fully factorised. 3f, there are 2 ways of doing this. Have a look at the answer sheet on Josie to get the other way. But these ones I love. These ones are gimmies. They haven't collected their like terms and simplified this. So you can just go straight in and go with a C minus 9. So I'm taking one of the C's and I'm taking the minus 9. And I'm taking one of the C's and I'm taking minus 4. Okay, so I'm getting the numbers from here and here. And now that's fully factorised. Question 5a, we're back to expanding again rather than factorising. So BODMAS tells me I've got to get rid of these brackets. And then once we've expanded, we'll collect up our like terms. So 4m times 2m makes 8m squared. 4m times negative 1 makes negative 4m. Negative 1m times 3 makes negative 3m. Don't forget that negative stays with that term, okay? Negative m times negative m makes positive m squared. Now we're going to collect our like terms. So I've got 8m squareds and another one, making 9m squareds. I've got negative 4m's and negative 3m's, so I've got negative 7m's altogether. (5b), we're going to expand and simplify. Get rid of the brackets first. 2x's multiplied by 5x's makes 10x squareds. 2x's times negative 7 makes minus 14x's. And we got our little negative 7x's on the end. That leaves us with 10x squareds and 14 minus 7, which is negative 21x's. 5c, expand and simplify. So remember that times that, that times that, that times that, that times that. So 3m times 2 makes 6m's. 3m's times negative 3m's makes minus 9m squareds. 9 times 2 makes 18. And 9 times negative 3m makes negative 27m's. Let's collect up our like terms. So if I take 6m's and I subtract 27m's, I've got negative 21m's. I've got minus 9m squareds, and I've got 18. 5d, expand and simplify. That times that, that times that, that times that, that times that. Okay, 4c times 4c makes 16c squareds. 4c times negative 3 makes negative 12c's. 3 times 4 makes positive 12c's, and 3 times negative 3 makes minus 9. Okay, we're left with 16c squareds. These two eliminate each other, and we've got minus 9 left on the end. 5e, you've got a couple of options here, but I'd be leaving 5 out of the mix at the moment. I'd just be parking that so that I didn't have to deal with it. So leave the 5 outside and drop yourself some brackets, and then just solve this section. So x times 4x makes 4x squared. X times 1 makes x. Negative 2 times 4 makes minus x, 8x rather. And minus 2 times minus 1 makes minus 2. Okay. Again, just leave the 5 there. Just hold 5 for a minute. Let's collect up our like terms. We've got 1 minus 8 makes a negative 7x's, and then we've got a minus 2. And now what we can do is we can expand this out. So 5 times 4x makes 20x squareds. 5 times negative 7x makes negative 35x's. And 5 times minus 2 makes negative 10. 5f, very similar to 5e, okay, leave the 8. Don't let it get mixed up in it just yet. Remember that this is the same as writing c minus 3 multiplied by itself, okay? So we can expand this out, leave the 8, drop some brackets in. C times c makes c squared. C times minus 3 makes minus 3c. Minus 3 times c makes minus 3c. Minus 3 times minus 3 makes 9. Collect up my like terms. And then you can expand it back out again. So you'll get your 8c squareds, your minus 48, c's, and your positive 72 on the end, and you're done. Question 6a is where these questions start to get pretty long. We need to expand it, and then we need to collect up our like terms. So let's get rid of the brackets first. So you know that this is really the same as saying c plus 5 multiplied by c plus 5, and then it wants you to add that to 3c minus 2 multiplied by 3c minus 2. Okay, so let's expand that out. C times c makes c squared, c times 5 makes 5c, 5 times c makes 5c, and 5 times 5 makes 25. 3c times 3c makes 9c squared. 3c times 2, negative 2 makes negative 6c. Negative 2 times 3c makes negative 6c. And negative 2 times negative 2 makes positive 4. And then if you collect up your like terms, so c squared and 9c squareds make 10c squareds. And then we've got 5 plus 5 minus 6 giving us negative 2c's. And then we've got 25 and 4 making 29. That is expanded. Now 6b is probably best tackled using index laws. Okay, so in index laws, when you're multiplying these together, remember the base numbers are multiplied together, but the little indices are added when you multiply. That's the first index law. Okay, so when we do 4x to the 3 multiplied by 3x squared, what we end up with is 4 3's make 12, and then you have x to the 3 plus 2 making 5. Okay, then that times that makes negative 4mx3. Negative m2 times 3x squared makes negative 3m squared x squared. And then negative m times negative m makes positive m. But remember that this has actually got a little 1 here. So 2 plus 1 makes 3. Okay, and now if you can, you go through and collect like terms, but none of these are like terms. It has to be exactly the same combination of letters with identical indices. So this is expanded. 6c is going to need you to use your indices laws again, okay, but what we'll do first is, just so it's nice and clear, remember this is the same as this number, whatever it is, multiplied by itself, okay? And so the first thing we need to do now is expand this out using indices laws, okay? So 3x to the power of 7 times 3x to the power of 7, 3 3's are 9, x to the 7 plus 7 makes 14. Then 3x to the 7 multiplied by negative y to the 3 makes negative 3 x to the 7 y to the 3. Then this times this makes negative 3 x to the 7 y to the 3. And then finally minus y to the 3 times minus y to the 3 makes positive y to the 3 plus 3 makes 6. In this instance, we are able to collect like terms because these two are the same. Okay, so what we end up with is 9 x to the 14, and then negative 3, negative 6 x to the 7 y to the 3, plus y to the 6, and it's complete. Okay, 6d. Again, a couple of ways of going about doing this one. First thing to note is, do you notice that it's a cubed? Okay, so this is going to be d to the negative 3 times d to the negative 3 times d to the negative 3. Okay, now this could get very confusing. So what I like to do is just deal with this bit first, or deal with those two first. Okay, so let's just drop this one here and not muck around with this one yet. And now we'll expand this bit. So d times d makes d squared. D times negative 3 makes minus 3d. Minus 3 times d makes minus 3d, and minus 3 times minus 3 makes 9. I'm going to just collect my like terms just so that there's not too much work to do here. Okay, now I can solve this by saying this times this, 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 and then collecting up any like terms that there might be. So d times d squared makes d to the 3. d times negative 6 makes minus 6d squared. d times 9 makes 9d's. Negative 3 times d squared makes negative 3d squareds. Negative 3 times negative 6d makes positive 18d's. And negative 3 times 9 makes negative 27. Alright, I can see that I can at least collect a couple of d squareds in here, so let's keep the d cubes, and then we've got minus 6 and minus 3, so minus 9d squareds, and then I've got some d's, so I've got 27d's, and I've got negative 27 on the end. And we're done. Question 7, all three questions are using index laws. Okay, so in the first one it's multiplication, so we know we're going to need to multiply these base numbers. So minus 2 times 6 makes minus 12. And then we've got A's and A's, okay? Now, the first index law tells us that when we're multiplying, we need to add the indices. So 2 plus 3 makes 5, and that's it. 7b, it's got brackets, okay? So the indices rule is that you have to multiply the index law is that you have to multiply these indices. But the trick is, don't forget that that also applies to this 3 at front, and there's actually a little 1 up there that we don't use. So this is actually 3, becomes 3 squared. So just so it's really clear, you don't need to put this line in, but I'm going to put it in. You got 3 squared, and then you got c to the 10. Okay, so the correct answer is 9c to the 10. Alrighty, and then with division in 7c, we know we need to subtract indices. Okay. Now there's a couple of cool tricks to these when they get complicated, but this one's simple, so let's keep it simple. The first thing to do is to sort out the numbers without moving them around. Okay, so what goes into 6 that also goes into 16? 2 does, so that becomes a 3, and that becomes an 8. And now we have a look for the letters. There are m to the 2's up here, and m to the 4's down here, so 2 of those will get eliminated, and then there, so we can drop those in. You'll have 2 m's left down the bottom, and then you got 2 p's at the top, or p squared, and you got a p down here, and 2 minus 1 makes 1, so that one gets knocked out, so you've got a p left up on the top.